Welcome friends, welcome to another video from Learn with Chetan, and in this video we are discussing about Sds-Page electrophoresis method. Sds-Page electrophoresis method is nothing but sodium dodecyl sulfate or sodium lauryl sulfate polyacrylamide gel electrophoresis method. It is the method which is used to separate the protein molecules on the basis of their molecular weight. Means we are separate protein molecules on the basis of their molecular weight. In the previous video, I already discussed about agarose gel electrophoresis method. If you haven't seen that video, please see the video, because if you see the agarose gel electrophoresis method, you have well understand about the Sds-Page electrophoresis method. In that video, we separate the DNA molecules on the basis of their size and charge. Okay. Let us discuss about principle of Sds-Page electrophoresis method. Principle. For the separation of protein molecules by the use of the electrophoresis method, polyacrylamide gel electrophoresis method, we must pass our protein samples through the gels. Here is the polyacrylamide gel, and we know that those protein molecules which having the smaller size particles or smaller size are easily passes through the gel matrix because of less hindrance or less resistance provided by the gel matrices or gel pores as compared to the large, because larger one molecules of protein have the more hindrance or more resistance provided by the gel matrices. Okay. In the polyacrylamide gel electrophoresis method, we can't separate the protein on the basis of size or on the basis of charge as in DNA, because DNA electrophoresis means in agarose gel electrophoresis method. In agarose gel electrophoresis method, we easily separates DNA on the basis of charge, because we know that DNA are always negatively charged particle and they are easily separated on the basis of the charge, and also on the basis of size we also separate the DNA fragments. But you see where the protein, in case of protein, we can't separate the protein on the basis of structure or size, because you know that protein are very complex nature, protein are very complex in the structure, and we can't separate by passing through the gels. Okay. And also in case of charge, protein are composed of various amino acids, means protein composed from the various different amino acids, and due to this, suppose this is the structure of protein. Let's discuss the principle. Suppose this is the structure of protein, complex structure of protein. This is the protein, literally the tertiary or quaternary structure of protein, and you know that protein contains disulfide bond. Suppose this is the disulfide bond, and protein consists of different amino acids, and different amino acid have different charges. Some are positively charged, some are negatively charged. Suppose some are negatively charged, some are positively charged, and again some are negatively and some are positively. Means protein has not unique charges and it contains different charges, and hence we are not predict that we separate protein on the basis of the charge. Yeah, there may be some conditions for the separation of protein in the Sds-Page electrophoresis method, and that condition or that modification we must do before the separation process. What that modification is that we must break this disulfide bond and also make these protein structure unique charges and unfold them into the straight chain. For that, we add one reducing agent in this protein mixture or in this protein. Which is this reducing agent? The reducing agent is beta mercaptoethanol. What happens after addition of beta mercaptanol to this protein? Beta mercaptoethanol targets this disulfide bond and reduces it, breaks it. Okay, this disulfide bond is now breaks. Beta mercaptoethanol breaks the disulfide bond. Okay, but still see that protein contains, till there is different charges on protein surface. negative, positive, but we want unique charge on protein surface. Okay, and we also unfold this protein structure into the straight chains. For that, we add one surfactant known as SDS. Okay, SDS. Literally, we add them at a time. Generally, we add beta mercaptan, ethanol, and SDS at a time into the protein mixture. But for your understanding, I explain it step by step. Okay. After addition of SDS, what happened? SDS is anionic surfactant, sodium dodecyl sulfate, or it is also known as sodium lauryl sulfate, and hence the title indicate that Sds-Page electrophoresis method, because SDS plays a huge important role in this process. Okay. After addition of SDS to this protein, what happens? SDS denaturates this protein into the straight chains. Okay, this complex structure of proteins are now gets converted into the straight chains. Some are larger, some are smaller, and some are moderate one. Okay, some are larger, some are smaller, and some are moderate. And also SDS can coat this protein surface with the negative charges. Okay, because SDS is anionic in nature, it contains many negative ions, and it has ability to coat these proteins. Okay, protein surfaces. What happens in the next step? We put these protein fragments or protein molecules in the polyacrylamide gel. Okay, we put them into the polyacrylamide gel. Suppose this is the polyacrylamide gel, and run this protein in the polyacrylamide gel. Suppose these are the wells to load these protein mixtures. We load them into these wells, and suppose this is the internal structure of the polyacrylamide gel. Internal structure of polyacrylamide gel. Generally, the polyacrylamide gel having internal structure is like a net-like structure. It contains some pores. These are the pores or matrices. We can say matrices. Okay. We run these different size or different sized protein through these polyacrylamide gel, and what happens? Those proteins having the less size or very small size in the structure, or very small size proteins, are easily passes through these pores. Suppose this is the running. Small proteins are easily passes through the pores and reach at the maximum distance. Okay, but what happens with the larger size proteins? Larger size proteins are trapped due to this is the pores, and due to these pores, very small pores, and pores provide many hindrance or large resistance to the large size particles, and due to these large size particles are not separated, and small size particles are easily separated through these pores. Okay, suppose these are the large particles, and in this method, in this fashion, we are separate the different size protein molecules by using the Sds-Page electrophoresis method. This is the simple principle behind the Sds-Page electrophoresis method. Hope so you will like this principle, and if you like this, then press the like button and hit the subscribe button, and please share